guys. So we are going to start with some notes today. If you read all the stuff that I posted, if you are not able to print off the stuff, which I don't expect you to, or if you don't want to take notes on a split screen, if you don't know how to split your screen, there's simple YouTube videos for you to do it. And if you still can't figure it out, email me and I will rewatch the YouTube video to explain to you. But if you are not comfortable with taking your notes on your computer while you watch or listen to me or look through the PowerPoint, you can just listen and then take your notes later once I give you the paper copy in class. Or if you can print it off, go and print it off. Whichever one works for you. So we are going to start today's lesson talking about Earth as a system. It is loading. Also, I am nice and cozy in my office. I have a blanket, so I hope that does not offend anyone. But we're going to talk about Earth as a system. So first of all, what is Earth science? Oh, another side note. As I go through the PowerPoint, as you can see here, the blanks, because if I look over here, I'm looking at my other laptop to look at the notes, just so, it lines up well. Everything red on the screen here will be what you fill in the notes on your paper or in your other tab. Just as a side note. So, what is Earth science? Earth science is the study of Earth. Earth doesn't just include rocks. We look at the rocks, which is part of geology. We look at the oceans, which is oceanography. We will also be talking about space, so that's astronomy. And we will also be talking about the air, so the weather, what's happening there, climate. That is meteorology. So there's like kind of 4 spheres of the Earth that we look at. And all of these spheres have cycles and they interact with each other. And all of this as a whole can be looked at as a system. It can also be broken down into different systems. But it all kind of goes together. That's kind of the main point here. So, is Earth an open or closed system? So let's kind of define that a little bit. Sorry, I move a lot and talk with my hands. That's just what we're going to be doing here. Sorry if that distracts you. But it also doesn't help that I have a spinning chair. That's just what happens. So let's look at Earth and define open or closed systems. So a system is just a type of model that's often used to describe the natural world. A closed system is a model that lets energy in and matter in, but only lets energy leave. So energy enters and may leave, but matter does not leave. So the two can come in, but only energy can go out. An open system, energy and matter both are free to enter and leave. So the big difference between a closed system and an open system is that in a closed system, matter can't leave the system. Once it's in, it's there. Open system, both matter and energy can go in and out. So as long as you kind of keep those two straight, energy and matter can go into both systems, but only energy can come out of a closed system. So we consider Earth a closed system. There's a few exceptions to this overall statement. That includes hydrogen leaves and meteorites enter. So whenever meteorites enter, hydrogen leaves, and that's technically matter. So that's the only exception that. Okay. So that should be the first 4 in your notes. And then we're moving on to 5. So you will kind of fill these in here. A volcano. Energy is released and matter is released. So if energy and matter are both released, that makes it an open system. A light bulb. Electrical energy enters and light is released. So light is a form of energy. It is not matter. So this is technically a closed system. So a tree. Sunlight, water, CO2, all go in. All three of those things go in. And then water and oxygen are released. And seeds and leaves are also produced or released. So if we have water, oxygen, seeds, and leaves coming out of the system, that should make it an open system, because if matter is leaving, then it has to be an open system. Okay, so let's look at the ocean. Sunlight enters, water enters through runoff or precipitation, and then water also leaves through evaporation. So water is a form of matter, and if it's leaving the system, that means it's an open system. And then boiling water. Again, another water example. Heat enters, heat and vapors are released. Now we got to think a little bit more about this one. What are vapors? Water vapor is the same thing that we were just looking at in the ocean. Whenever evaporation happens, the water vapor is a gas form of the water. So if vapors are released, that means matter's leaving the system, and boiling water is going to be a open system. So the only closed system you should have on this list is a light bulb, because that's the only one that does not release matter. Let's see. So let's take a second, and if you look at your notes, there's a little box there for some prefixes that you should know. Atmos is vapor or steam. That talks about the atmosphere. Hydro, of course, is water. Bio is life. That's whenever we're going to be talking about the biosphere. Geo is earth. Litho is stone or rock. So cycle, CYCL, kind of talks about like a circle or a wheel. And then thermo is heat. You don't like have to burn those prefixes into memory, but if you know what those prefixes mean, you can kind of decipher some of the words we'll be using in the class. So, humans and the planet Earth. This really isn't in your notes. That's okay. It's just that it's important to know that whenever we study the Earth, we normally view it through how we interact with it. So, some key aspects to keep in mind is that our population affects the Earth, the resources that we use affects the Earth, and basically everything we do has an impact on Earth as a system. And again, science in general helps us to figure out how to do these things sustainably, how to not deplete our resources, and how to maybe alleviate some of the impacts of what we do on the Earth system. So that's what science is. We're figuring out what the Earth system does altogether, and we're figuring out our place in that system and what effects we have on it. That's just a pretty picture. So the four spheres. So this is 6 in your notes. The four spheres. The first one, again, I mentioned all these earlier, but the four spheres, atmosphere. That's going to be your blank there. This is just the gaseous envelope surrounding the Earth. This gives us oxygen, carbon dioxide. It also blocks and absorbs the radiation from the sun. And this is where your weather happens. We'll get more into meteorology. That's the study of this sphere later, I think after oceanography, but later on this semester. So this is where all your weather occurs. We'll learn the difference between weather and climate and all of those fun things. Now your geosphere. This is probably my favorite section because I'm a rock person. So the geosphere is all the physical features of the Earth, except water. So this includes rocks, mineral resources, metals, mountains, beaches, and the lithospheric plates. I will also refer to that term as tectonic plates. So, I'll switch back and forth, but you do need to know the tectonic plates are lithospheric plates. So that's the geosphere, all the physical stuff. Now, the hydrosphere, this is all of your water. This includes oceans, rivers, lakes, groundwater, and all of it's continuously recycled. So that goes to the water cycle. That means that water never truly leaves. It's in a different part of the cycle. It can be evaporated in the gas form, it can be frozen in the solid form as ice, it can be in the ground, it can be in the ocean, rivers, lakes, all of these things. Um, it is useful to know that 97% of all the water on our planet is salt water, and that leaves the other 3% to be fresh water. And of this 3% of fresh water, only 1% of that is usable. So we have all this water, but we can't necessarily use all of it. So that kind of makes some things tricky, brings a lot of things into question, but that's what we're working with. So that's the hydrosphere. And then the biosphere. If you remember the prefixes that we talked about a moment ago, bio means life. So this is all living things. That's going to be plants, animals. We're technically an animal, so us, all the flora and fauna. So all of those things make up the biosphere. So in this picture here, you can see all four spheres. This one here is going to be the atmosphere. And then down here we have water. So clearly that's going to be the hydrosphere. And now we've got two kind of interacting with each other here. All this rock face, all this open rock, that's going to be your geosphere. And then what about all these plants? Plants are living things. So living things fall under the biosphere. So we have the atmosphere, the hydrosphere, the geosphere, and then all the plants, and if there's any animals in here, that's your biosphere. I talked earlier about the water cycle. This, you've studied the water cycle multiple times. I'm not going to go into super huge detail. We will touch on it whenever we talk about erosion and deposition and groundwater. It'll be woven in throughout several of our units. But if you don't know the water cycle, come talk to me. We will break it down, or you can study this image or any image you found on Google search. So the water cycle is super important. It basically allows life to happen on our planet, and it plays into all the other cycles that we can think of almost. And now we get to the energy cycle. So I will also refer to this as the energy budget. And this is important because, yes, we have to have water to live, but we also need an energy source. And our energy source here is going to be the Earth. So all of the solar energy coming in, as you can see in this picture, is 100%. And that's the beginning of the energy budget. And then some of that's reflected in the atmosphere, reflected by the clouds, reflected by the Earth's surface. So some of this radiation from the sun is just automatically reflected. And then some of this light gets trapped in the atmosphere because it bounces from particle to particle, all crazy like that. And then it gets absorbed by the clouds, which is the bottom, closer to us layer of the atmosphere. And then some of it gets absorbed by the ground. So this is kind of how it can be hot all day, and then even though the sun comes down, the ground is still warm because it's radiating out that heat that it absorbed, which you can see here. So basically, the energy budget, it's always balanced, and it's basically just a breakdown of the energy coming into the earth as a system and then out. So again, the energy budget is looking at the earth as a system, and it's showing us kind of what happens to all the solar radiation that comes in. So solar energy, it is 99.985% of the total energy budget. So the sun produces energy through nuclear reactions. And then all of this energy, it drives winds, ocean currents, waves, and the weather. And that's all through a convective heat transfer process. Convection is something that we will talk about in every single unit that we see this semester. So if you don't remember any type of heat transfer, remember convection. So the next type of energy that we get, it's only 0.013% of the entire energy budget, is geothermal energy. So if we go back to our prefixes, geo means earth. So this is energy that comes within the inside of the earth. We will talk more about this later, but the inside of the earth is molten and it's very hot, so it produces some heat. Some people actually heat their houses through geothermal heat. It's not as popular as, the normal stuff, but it's there. So this energy drives the movements of the earth crust. So that's the movement of the tectonic plates, which again we'll talk about more later. But this movement of the crust creates volcanoes, earthquakes, and then it also creates like the hot spring geysers and stuff like that. And this type of energy plays a huge role in the rock cycle because if we're moving the Earth's crust or the tectonic plates, that means we're also creating new rock. So this is a very important part of the rock cycle as well. Another type of energy is tidal energy. This is 0.002% of the energy budget. This results from the moon's gravitational pull on the Earth's oceans. Again, we will get more into that. And it's powerful enough to slow down the Earth just a little bit. So the moon's gravitational pull does have energy, but it's not as prevalent as the others. So let's see. Yeah, so I've kind of said it all throughout this little lecture, but the 4 subjects of earth science are these: meteorology, that's the study of the atmosphere; geology, which is my favorite because I studied rocks in undergrad, but geology is the study of rocks, which is the physical aspect of the earth; oceanography is the study of the ocean; and then astronomy is the study of space. And we're going to be starting out our unit with space stuff after we go over a few review sections. And that should be all of your notes. Again, all the blanks should be in red, even with the titles. And that is it for your first lecture. I will be doing the scientific method one shortly, so be on the lookout for that. But y'all have a good day, guys, and email me if you have questions.